It's Clive Rocksinger here again. I learned a lot this morning. I finally got a bridge rectifier hooked up to this circuit, but learned some very interesting things. What I found was that I fried some wires, and it turned out that I've got my low voltage going into the bridge rectifier, which is just 4 diodes, but I didn't respect the wattage going into the inputs, and I need to spend a fair bit of time now making up all high wattage leads, and I'll have to custom make them all from the high current breadboard, because the wattage is significant. It didn't just heat them up, it fried it good and proper, as you can see. And I'm also now going to make moves towards getting a fire extinguisher which can really set fire to the joint. And the other thing I found the other day is when I'm doing soldering, what I found is that when I solder, what I was essentially doing was doing this. Apparently what you've got to do, and it seems such a silly thing, but it's so simple, but it's kind of logical. You have to tin the tip, and what that is what it does is it makes a liquid bond between the soldering iron and the work, go away of it, and it increases the heat on the copper, and then it enables the conduction of the heat through the copper to increase, quite dramatically, and then you can put the solder on. And I've been making that mistake for years. I keep getting hotter and hotter irons. Little Jenny there, keep me company. My girlfriend, that's a super high wattage gas one. Well, when I say high wattage, it's a high heat level. And I was always having trouble with this, and all it was I just wasn't tinning the tip. You got to get it wet, and once you get it wet, it sticks to the copper, and then you can solder. So I always hate soldering. I'm terrible at it. I'm a panel beater. I'm no good at soldering. This circuit, I've got it up and running. I'll get that on AC. Now this is going through my high wattage resistor. I've got an AC waveform going through there, and it's going into a bridge rectifier here. So there's 4 diodes. The measurement I'm getting is weird because I'm actually taking the measurement from the wrong part of the circuit, I believe. But if I set this up, yeah, I'm getting 2 volt there, which is nice and low, which is what I wanted. And if you set the crow up, waiting, and there you have it. Now that's a rectified waveform, but I believe what it is I'm taking that from the wrong part of the circuit. What it's supposed to be, it's supposed to be flat, lump, and it's supposed to be in the middle like that. So that's supposed to be flat on the bottom, so I'm taking that from the wrong part of the circuit. I don't leave that running. Fire is not my friend. So, looks like we're part of the way there. So when you're dealing with these circuits now, this actually comes down to, I'm going to get cut off again, I do this all the time. The thing is when you get a pre-designed circuit, the wattage is already taken up by the circuit, but when you're designing a circuit, and as you can see here, what I'm doing is wiring up just the rectifier itself, you've got to have a very low voltage going through it, otherwise you're going to fry your component. If I had to hook that straight up the transformer, I would have gone up in smoke. And that's why you've got to have the reduced waveform going in, but I didn't account for the wires going into it. You've got to be very careful about your input wires. And all it really is just your negative and your positive going into the circuit. The circuit soaks up all the wattage, so there's no problem there. It's mainly when it's coming from your transformer. That's the killer. So, Clive Rocksinger over and out.